Good evening, everyone. Welcome to my YouTube channel, Math Saptara. Today we are going to see second property of Jacobians. Okay. So, second, second property of Jacobians. Okay. Or you can say property second. Okay. So let U and B be functions of R and S, and R and S be functions of X and Y, then Jacobian of, because if U and B are functions of R and S, okay, if if U and B, if U and B are functions of X and if U and B are functions of R and R and S functions of X and Y, then finally U and V are functions of X and Y. So we want to calculate Jacobian of U and V with respect to X and Y. So what will be the formula for this? This will be nothing but Jacobian of UB with respect to R and S into Jacobian of R and S with respect to XY. We are to prove it. Okay. Proof. Jacobian of UB with respect to R and S into Jacobian of RS with respect to XY. What is this actually? First, we have to write this. So what is this? Del U upon del R, del U upon del S, del V upon del R, del V upon del S. So this is U. Okay. And this is del R upon del X, del R upon del Y, del S upon del X, del S upon del Y. Okay. Now, what is this? So multiply what you will get. After multiplying, what you will get? You will get, so del U upon del R, del R, del X plus del U, del S, del S, del X, del U, del R, del R, del Y plus del U, del S, del S, del Y. Okay. Del V, del R, del R, del X plus del V, del S, del S, del X, del V, del R, del R, del Y plus del V, del S, okay, and del S, del Y. Now by chain rule, what is the value of this? By chain rule, the value of this is nothing but del U upon del X. By chain rule, what is the value of del U upon del Y? What is the value of this? Del V upon del X. What is the value? Del V upon del Y. So finally, what we got? This is nothing but Jacobian. This is nothing but del U B del X del Y. Hence, del U B upon del X del Y is equal to del U B del R del R S del X del Y. So chain rule is proved. Okay. Note that note second property second property of Jacobians is also called chain rule of Jacobians. The second property of Jacobians is also called chain rule of Jacobian because it is a chain rule. Okay, it is a chain rule. Now, second note is that if U, V, W are functions of R, S, T and R, S, T are functions of X, Y, Z, then Jacobian of U, V, W with respect to X, Y, Z is given by Jacobian of U, V, W with respect to R, S, T multiply by Jacobian of R, S, T with respect to X, Y, Z. Okay. Similarly, you can increase the variables. Okay. You can take more 4, 5 variables like that. In this way, you can proceed. Same chain rule formula will follow. So, example, find the value of the Jacobian, find the value of Jacobian del UB del R theta where U is equal to x square minus y square, V is equal to 2xy and x is equal to r cos theta and y is equal to r sin theta. Solution. Now, u and v are functions of of x comma y, and x comma y are functions of r and theta. Okay. So we are to calculate Jacobian with respect to Jacobian of UV with respect to r and theta. So we will apply this formula. Okay. We apply this formula. Okay. So what is del UV, del x, del y? Del u, del x, del u, del y, del v, del x, del v, del y. Okay. So del u upon del x, what is that? Because u is x square minus y square, so it will be 2x and it will be minus 2y. Okay. And b is 2xy, it is 2y and it is 2x. So what is this? 4x square plus 4y square. So it is 4x square plus y square. Okay. Okay. Now, because we are calculating, okay, this. Now we can, because x is equal to r cos theta and y is equal to r sin theta, because finally we have to calculate Jacobian of u and v with respect to r and theta. So what is x square plus y square? That is r square, because cos square theta plus sin square theta is 1. Finally, we have to change this to r and theta because we have to find the Jacobian of u and v with respect to r and theta. Now, similarly, we'll calculate Jacobian of x and y with respect to r and theta. So, what is x? So, x is equal to r cos theta. So, this is cos theta. Okay, and this is minus r sin theta, and this is sin theta r cos theta. So this is r cos square theta plus r sin square theta. So r you can take common. So what is this? This value is 1. So this is r. Okay. So finally, what is the value of this? Del ub del r theta. You multiply Jacobian. That is 4 r square and this is r. Okay. 4r cubed answer. Because Jacobian of, because we have written this formula here, Jacobian is multiplication of these two. Okay, that is why you multiply all these two values and you will get this. Okay. So 4r cube we got. Okay. So next question, example 2. If u is equal to e to the power x cos y, b is equal to e to the power x sin y, where x is equal to LR SM, y is equal to MR minus SL. Okay. Find Jacobian UB with respect to R and S. Okay. Here L and M, these are constant. Okay. So now we have to calculate. So first we have to calculate del U Jacobian of UB with respect to X and Y. So what is that? So what is that? E to the power x cos y, e to the power x sin y minus e to the e to the e to the power x sin y, e to the power x cos y. So this will be e to the power 2x cos square y plus e to the power 2x sin square y. So you take e to the power 2x common, cos square y plus sin square y. So this value is 1. This value is e to the power 2x. And Jacobian of xy with respect to r and s, what is that? Del x, del r, del x, del s, del y, del r, del y, del s. So what is that? So this is with respect to x, partial derivative of x with respect to r, that is L. Okay, with respect to s, it is m. And partial derivative of y with respect to r, m. And this is minus L. Okay. So what is this? This is minus L square minus m square. So this is minus L square plus m square. Okay. Okay. So here we got this one. We can put the value of x here. What is x value? LR plus SM. Now by property 2, second property, or you can say by chain rule of Jacobians, we get what we get? Del u be Jacobian of u with respect to r and s. That is Jacobian of u be with respect to xy into Jacobian of xy with respect to r and s. So what is this value? This value e to the power 2 LR plus SM. LR plus SM into L square plus M square is minus, so minus will come here. So this is the answer. Okay. So today's lecture up to this. In this lecture, we have seen what is the second property of Jacobians, and we have done two examples. If you have any problem related to this, you can comment on my YouTube channel. Like, share, comment, and subscribe my YouTube channel. Thank you very much for today's lecture. Thank you very much. We will see you for next lecture.